Good morning students, I am Dr. Betsy Claribel, Assistant Professor, Department of Chemistry. In this video, we are going to learn about the general methods involved in the extraction of metals. This comes under Unit 3, Metals and Metallurgy. So first we have to know about the metals. So metals and their alloys are extensively used in our day-to-day life. So they are used for making machines, railways, motor vehicles, bridges, buildings, etc. So not only like buildings, they are also used for making ornaments like the metals like gold, silver are used for making ornaments that we use in our day-to-day life. So most of the metals occur in the combined form, but only a few metals they occur in the free state such as gold, mercury, etc. So when they occur in the combined form, it is necessary for us to separate them. So the separation or the extraction of metals from their alloys is very important. So therefore the study of recovery of metals from their ores is a very important thing. Ore. So an ore is the mineral with which the metal is present in appreciable quantities and from which the metal can be extracted. So in this picture you can see it is a picture of ore. So it contains both the metal and the other impurities which is present along that. So we are going to extract the metal from the ore, which is a combined form. So the metal along with the impurities is called ore. So here we are going to extract the metals from the ore. So the choice of process depends upon the nature of the ore and the type of the metal. And the metal content in the ore can vary depending upon the impurities present in it. So extraction of metals. So metals exist mostly in the form of salts along with other minerals to form an ore. So these impurities should be removed with the help of different inorganic separation techniques. So the separation techniques we are going to see one by one. So the general methods involved in the extraction of metals are first the crushing and grinding of ore, then the concentration method, the third one is the froth flotation, the fourth is the roasting process and calcination, and finally chemical reduction processes. First, the crushing and grinding of the ore. So in this process we are going to crush the ore and then grind it. So these two are very important process, which is the initial step for the extraction of metals. And here when we crush the ore and grind it, we are increasing the surface area for more efficient extraction in subsequent steps. So crushing involves the breaking down large chunks into smaller particle and then followed by grinding. The grinding follows the crushing and further reduce the size of the ore, and we get a powdered form, usually using mills such as ball mills or rod mills. So in this picture you can see on the right side is the ball mill which rotates and it grinds the ore, and on the left side you can see the windmill crushing model. Here the ore is crushed and the size of the ore is reduced. Then the concentration method. This is the second method. Here the concentration is a process of removing impurities, that is gangue, from the ore to increase the percentage of the metal content before it undergoes further oxidation. So here we are going to increase the concentration and remove the impurities from the ore. So various methods are used depending on the nature of the ore. The main concentration methods are gravity separation, froth flotation, magnetic separation, leaching and flotation, which is made especially for the oxide ores. So the first method is the gravity separation. So here, based on the differences in the densities of the ore or the gangue particles, so the heavier particles will settle down at the bottom. So common methods to obtain this is by shaking tables, spirals, etc. So the heavier particles will settle down at the bottom. So this is done through the gravity separation method. The next one is the froth flotation. Here it is used especially for sulfide ores like copper and lead. So the ore is ground into fine powder and mixed with water and chemicals. So air is bubbled through the mixture and a froth is formed. So the impurities will stick on to the froth and attach to the bubbles and rise to the surface, forming a froth that is skimmed off. Thus we can separate the metal from the impurities. So this method is called the froth flotation method. Then third one is magnetic separation. So with the help of magnet, we can easily separate the metal from ore. So this is used for ores containing magnetic materials, example magnetite of iron. So here a magnet is used and the metal is separated from the impurities. The next process is the leaching process. Here it is a chemical process where the ore is treated with a solvent. The solvent like acid, base or cyanide to dissolve the metal solution. Then the metal is recovered from the solution through precipitation or electrolysis. Then the fifth step is the flotation, which is mainly used for oxide ores. So when used when ores are oxidized and not easily concentrated by gravity or magnetic separation. So here special reagent is added and it helps the formation of froth, so that the metal or the impurities will stick on to the froth and it is removed. So here next we can see in detail about the froth flotation process. So it is widely used method for the concentration of ores, particularly for sulfide ores like copper, lead and zinc. So here froth flotation is a crucial technique in modern metallurgy which enables the efficient extraction of metals from complex ores, that is a large ores. So here the steps involved in this process are grinding, then slurry formation, then air bubbles are formed and finally froth formation and then separation. So here the froth is formed on the top and we can easily separate. Then roasting process. So roasting process is a pyrometallurgical process used to extract metals from their ores by heating them in the presence of oxygen. So here we are going to heat the ore at very high temperature. So it is primarily applied to sulfide ores to convert metal sulfides into oxide. So here the sulfides are converted into oxides and then making it easier to extract the metals. So the chemical reaction that takes place here is the zinc sulfide is heated, that is it is combined with oxygen to form metal oxide. So then it is converted into metal sulfide and then it can be easily extracted from the metal. Then finally the sulfur is removed and formation of oxide takes place. Then calcination. So calcination is a process used to heat. So here also we are going to apply a large amount of heat in this process and we are going to extract the metal. This process is used to drive off the volatile components like water or carbon dioxide. So here heating process is done. The ore is heated in the furnace at very high temperature of about 300 degree Celsius to 900 degrees Celsius and without the presence of air. The main thing that we have to note that in calcination process there is no presence of air but it is heated at very high temperature. So here decomposition takes place. So the heat causes the chemical reactions that decompose to form the ore, to get the ore or drive off the volatile components. So as a result finally we can easily separate the metals. So that's all about the general methods involved in the extraction of metals. Thank you.